Figuring out how much energy permeates the center of the Milky Way, a discovery reported in the July 3 edition of the journal Science Advances, could yield new clues to the fundamental source of our galaxy's power, said L. Matthew Haffner of Embry-Riddle Aeronautical University. The Milky Way's nucleus thrums with hydrogen that has been ionized, or stripped of its electrons so that it is highly energized, said Haffner, assistant professor of physics and astronomy at Embry-Riddle and co-author of the Science Advances paper. Without an ongoing source of energy, free electrons usually find each other and recombine to return to a neutral state in a relatively short amount of time, he explained. Being able to see ionized gas in new ways should help us discover the kinds of sources that could be responsible for keeping all that gas energized. University of Wisconsin-Madison graduate student Dhanesh Krishnarao (DK), lead author of the Science Advances paper, collaborated with Haffner A. Before joining Embry-Riddle in 2018, Haffner worked as a research scientist for 20 years at UW, and he continues to serve as principal investigator for the Wisconsin H-alpha Mapper, or WHAM, a telescope based in Chile that was used for the team's latest study. To determine the amount of energy or radiation at the center of the Milky Way, the researchers had to peer through a kind of tattered dust cover. Packed with more than 200 billion stars, the Milky Way also harbors dark patches of interstellar dust and gas. Benjamin was taking a look at 2 decades worth of WHAM data when he spotted a scientific red flag, a peculiar shape poking out of the Milky Way's dark, dusty center. The oddity was ionized hydrogen gas, which appears red when captured through the sensitive WHAM telescope, and it was moving in the direction of Earth. The position of the feature, known to scientists as the tilted disk because it looks tilted compared with the rest of the Milky Way, couldn't be explained by known physical phenomena such as galactic rotation. The team had a rare opportunity to study the protruding tilted disk, liberated from its usual patchy dust cover, by using optical light. Usually, the tilted disk must be studied with infrared or radio light techniques, which allow researchers to make observations through the dust, but limit their ability to learn more about ionized gas. Being able to make these measurements in optical light allowed us to compare the nucleus of the Milky Way to other galaxies much more easily, Haffner said. Many past studies have measured the quantity and quality of ionized gas from the centers of thousands of spiral galaxies throughout the universe. For the first time, we were able to directly compare measurements from our galaxy to that large population. Krishnarao leveraged an existing model to try and predict how much ionized gas should be in the emitting region that had caught Benjamin's eye. Raw data from the WHAM telescope allowed him to refine his predictions until the team had an accurate 3D picture of the structure. Comparing other colors of visible light from hydrogen, nitrogen and oxygen within the structure gave researchers further clues to its composition and properties. Advertisement: at least 48% of the hydrogen gas in the tilted disk at the center of the Milky Way has been ionized by an unknown source, the team reported. The Milky Way can now be used to better understand its nature, Krishnarao said. The gaseous, ionized structure changes as it moves away from the Milky Way's center, researchers reported. Previously, scientists only knew about the neutral, non-ionized gas located in that region. Close to the nucleus of the Milky Way, Krishnarao explained, gas is ionized by newly forming stars, but as you move further away from the center, things get more extreme, and the gas becomes similar to a class of galaxies called liners, or low ionization nuclear emission regions. The struck. They have centers with more radiation than galaxies that are only forming new stars, yet less radiation than those whose supermassive black holes are actively consuming a tremendous amount of material. Advertisement. Before this discovery by WHAM, the Andromeda Galaxy was the closest liner spiral to us, said Haffner. But it's still millions of light-years away. With the nucleus of the Milky Way only tens of thousands of light-years away, we can now study a liner region in more detail. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new technology updates. Bye bye.